Hello friends, welcome back to my channel. In this video, I am going to solve exercise question from book Topics in Algebra from chapter 4 Vector Spaces and Modules. Question is, if V is finite dimensional and W is a subspace of V such that dimension of V is equal to dimension of W, prove that V is equal to W. Now proof. It is given that V over field F is a finite dimensional vector space, and let us consider dimension of vector space V is n. Further, let B containing n number of linearly independent vectors u1, u2 up to so on un is any arbitrary basis of V. Also, we know that W is a subspace of V such that dimension of W is equal to dimension of V. Now we have considered that dimension of V is n, therefore dimension of W will be also equal to n. Now let us consider set B dash containing these n number of vectors e1, e2 up to so on en is any arbitrary basis of subspace W. Now we know that W is a subspace of V, therefore W will be a subset of V. Call this as star. Now since W is a subset of V, all these vectors are also vectors in vector space V. Therefore, the set B dash containing vectors e1, e2 up to so on en, which is basis of W, will be a linearly independent subset of V. Next, we have one theorem which states that let V over field F is a finite dimensional vector space with dimension of V is equal to n, then any linearly independent set with n number of elements is a basis of V. We have also proved this theorem in our earlier video. You can see proof from there. Now, from this theorem, we can conclude that the set B dash containing these n number of vectors e1, e2 up to so on en is also some basis of V. Now let us consider any arbitrary vector, say u, in vector space V. Now since B dash containing vectors e1, e2 up to so on en is a basis of V, so we can write this vector u in vector space V in this way, in this unique way, such that u is equal to a1 e1 plus a2 e2 plus and so on plus an en, where these ai's are unique scalars coming from field F. Now from here we can say that U belongs to linear span of these vectors e1, e2 up to so on en. Now since B dash is a basis of vector space, subspace W, and U belongs to span of these vectors e1, e2 up to so on en, therefore U will be a vector in subspace W. Now from here we have considered that U is any arbitrary vector in vector space V, and also we come to the conclusion that U is also a vector in subspace W. Therefore, from 1 and 2 we have V will be a subset of subspace W, and we call it as double star. Now, from star, that is W is a subset of V, and from double star, that is V is a subset of W, we have set V is equal to set W, and this proves our result.